What makes an object to become non-manifold and how to fix them? Hello everyone, in this video I'm going to discuss the top 7 problems that can make an object become non-manifold and how you can fix them. Number 1 is merging intersecting volumes. Every object has a proper volume. It must be closed and in order to be a volume, and if you're going to combine one or two objects, you need to use a tool that's in Stitch and Scoop. They're called also Boolean tools. You can either use union to combine them, and if you can see, once I combine them, you can see it creates the cuts over here. And not only does it create the cuts, it actually cuts out the inside piece that sticks into it. If you finalize it, you can see it will cut out and remove the inside piece. Similarly, you can use any of the other Stitch and Scoop tools to remove a difference or to use only the intersection part. But regardless which tool you're using, all of these will actually properly handle the intersection and make sure the cuts are created properly. If you're going to group them or merge them, if you're going to use the combine, you have an option to group. Group is also available in the edit menu or the hotkeys. Combine is just like putting together all of the options to combine in one place. You also have merge, you can merge them together, or union together, which is the same from Stitch and Scoop. If you use merge or group and an object that intersect each other, you will have a problem. Merge is final, so it will be difficult to remove them. Group, you can always ungroup using the command key or from the edit menu to ungroup. If you handle them as a group, an intersection will be a problem. So for example, if I'm going to group this as a group, and now I'm going to add a third object as an intersection, and now I'm going to do a union. So even if I'm going to use the proper tool, I'm going to use the union tool, it will actually solve these intersections over here, but it will not solve the one that was already grouped because it treats them as a merged object. And you can see over here it did not create the cuts, and similarly it also left the inside part. So before you use union or any other tool, you have to make sure you split all intersections. Now I keep on stressing the word intersections, and I want to show you why. Because in some cases either merge or union are very helpful. So over here I have a simple sphere. I copied the edges, an edge loop over here, to copy a circle, created a profile, and I added here a third sphere over here. Now my goal here is to make many copies around, so I'm going to use the copy offset pivot tool, and not skew pivot, and I'm going to add, let's say, 11 copies. So if I make 11 copies, actually I end up having 12 objects together with this. Now I'm going to group them together, or actually merge. It's just the same thing, doesn't matter. If I'm going to go combine and go merge, so I'm actually merging them all together. Now this actually is not a problem because they are not self-intersecting, so none of these objects touch each other. However, they are very helpful before doing union, because now, or subtraction. Let's say if I'm going to go subtraction to remove that, and now you can see this actually works very quickly and very nice and cuts out everything. Now the reason this is helpful is because union or any of these other intersection tools will work on each object individually. So if you think about that 12 copies, 12 objects plus the sphere 13th, you need to check each object against each object. So this kind of multiplies and becomes quite extensive. And if you have a more complex object, this may be too much and you may have to do a few at a time and so on. By grouping them together, I actually tell them, either merging or grouping, I tell the tool this is one object, and then it only has to intersect one object with the other. Now this is why if they intersect each other, they will not solve it. But if they don't intersect, I know they don't intersect, I don't care if they don't check between all of the objects. All they look at if this grouped object is also intersecting the bigger object, which in our case it was, and then it solved it. So this is basically the problem with how to solve for combining, merging, intersecting volumes. Number 2 is flip normals. This is actually not so much about non-manifold as it is just how it calculates the volume, and it can disturb how the tool is working. So I have here again 2 objects, a cube and a sphere. In the sphere I flip normals, I use the flip normals tool, and now I'm going to use Stitch and Scoop. And you can see the same example I used before, but now it will misbehave. So if I do something like this, you can see the results are totally different, not what's expected. If I use, for example, the union tool, it's also not combining them, and the same with intersection, it's just giving unexpected results. And the reason here is because the normals is the direction it faces, and this technically faces inside out. So based on the way its faces, it's actually doing the proper thing, but we don't know. So how do I handle normals? So first off, you have a tool over here that's called, now you see I can change it to no coloring. You wouldn't even know something is wrong. And if you turn on to backface coloring, you can see something is wrong. And if you see something misbehaves, then many times the problem is with flip normals. As you see later, this can also detect other things like self-intersections, which we'll see later on number 6. Now to fix it is the same way I did it actually, which is going to utilities and flip normals. So you can flip back, it says it's fixed, and now you can see everything's okay, and now it will work as expected. Number 3 is touching instead of intersecting. Here we have another example where I took the same sphere with the circle I had around, and I create a small sphere again and use the follow path to extrude and make this shape over here. Now for this I'm going to make another copy. You can click Command C or just a copy over here, and I'm going to isolate the selected copy so I can see the operation. What I'm going to do here is also color this. I think I may need to color it again. Let's see. We'll see in a minute. I'm gonna do intersection like this, just the intersection, and I close it. So actually, yes, I do need to make sure that actually the outside has a color. You see later why color is very important over here. So this is basically over here. Okay, so now what I'm going to do here is I'm left just with this piece. Now I'm actually gonna hide this away, and I'm gonna bring back the other hidden objects, these two, and now we're gonna use a different operation, which is remove, and I'm gonna remove this object over here. Okay, so now what I have over here is I have a sphere that has cut out, use the same circle to cut in this piece, and now I use from the first operation, I use this that actually glues them together. Now if I'm going to change the color over here from this object, you wouldn't even notice a difference because they're almost identical, the same. Actually it's not exact color, but it's basically, it looks, actually it was the same color, just the highlight as well. I think if I finalize this, yeah, you see it's actually the same color. Maybe slightly different, but nevertheless that's not the point over here. So if I have these two objects, I'm going to combine them together. The problem here is that this object fills in the place of the previous hole without any intersection, meaning because there's not even a single slight piece from this object that touches the volume of the other object. This part, the small circle, has a volume, it's good, no problem. The other one has a volume, but they do not intersect, they touch each other. If I'm going to make a union now, this may give me a result, or sometimes an error. You see, enable non-manifold meshes. It is manifold, it's just that it's not able to detect because there's nothing intersecting. Solution for this is to scale it. The best way is to scale it proportionately, so you can later bring it back. And let's say this is 100 over here. I'm going to make it 100.5, just to show you can actually make the fraction more. Actually, even 0.1 should probably work. Just by a fraction more. And now I'm going to make a union to combine them together. And now everything works perfectly fine. So the reason I said about the color is, so now I can go back to material selection, and I can isolate this, selecting this quick. And now I can go back to my scale, and again I can turn on the key proportion, so it scales it, and I make it back to 100, and no harm done. Everything works perfectly fine. You can now actually change back the color, and everything would be perfectly fine without a problem. So this is basically how you solve touching objects that do not intersect each other. Connecting edges without volume. This is probably by far the most complicated one. Let's take a look. I have a drawing over here. If I look at the turn on vertex, you'll be able to see, you can see this is connected over here. From a 2D drawing perspective, we look at areas and polygons. So this is perfectly fine. You have a closed part over here that's actually a closed polygon, and it includes an area, which is fine. You can calculate it without a problem. Same with the other side, and they have no problem. But when it comes to 3D, if I'm going to extrude that, and let's say I make it 100, this is now a problem because you have a volume. In 3D, we need to look at the volume. And as far as the volume is concerned, it has one volume over here, one volume over here. Now, if they would have been completely split in the middle and moved aside, I don't care if they're considered as a single object, combined, merged, or grouped together, there will be no problem, as I said before in the previous examples. But if they are combined together, in this case they're joined, like the back face, or joining them, they're completely, and also merged vertices, they're completely joined together, then they must have a volume connection. In this case, there's no volume. If you put in, for example, water on this side, it will not be able to go over to the other side because it's choked over here. There's no volume going over. Okay, so I'm going to show you actually a few examples. This will be the first one, and show you how to fix them. Because in many cases, if you have more complex examples, one option could be useful, better than the other, so it's good to show you a few examples. First one here, I'm going to show you, you're going to go to Edit Details, and EC already gives you a message non-manifold, because every tool that may need to have manifold options will actually give you this message, so you know to be aware that there may be some issues. So I'm going to move in over here, section 5, I'm going to type in 5, I'm just adding an edge. And now in some cases you actually have a problem adding a second edge because the non-manifold, the edge is not always easy to add. So I actually want to show you how to solve this. So first thing is you can just go from the other side, and you see actually this gives you a problem. Actually it's interesting, sometimes happens, sometimes not. But in some cases when you're trying to work on an edge like this that is not manifold, it does some wrong calculations. So what I'm going to do here is I'm going to draw in a section over here, and once I draw it in, I actually don't have the option to make it close to it. And this is actually helpful in case you have like a face that has a lot of other faces that you cannot simply drag something. So I'm going to go to the collapse tool, and I'm going to add an offset of 5, and I'm going to collapse from here to here. If I can click on it, okay, here to 5, and same thing in the bottom, collapse from here to here, and because I have an offset of 5, this basically offset it, and you have a connection of 5. Now I'll go to remove. I have to turn off create keep non-manifold, so I can use this other option, and I'm going to remove a face, and I'm going to delete this face and delete this face. Now you could close the tool and use the face selection, simply delete them, but it's easier if you continue the same flow. Now I'll go back to the collapse tool, I remove my offset, and I change it to both, so it snaps in the center, and I'm simply going to snap this to this, and same thing over here, this to this, and close it. And in this case, look at what I got over here. We got a beautifully manifold because it added this volume over here, and now it will not give me any issue. Now technically you could have extruded the back to do the same thing, just extruded this part, add an extension. But in that case, you would have, first of all, the extrusion, if you have only this one edge that's not manifold, may sometimes misbehave. But even if you get it to work, there's ways to make it work, it will change the design. So this idea that I just showed you actually keeps the same design, it just kind of added over here. The other thing is that I've tested before that actually if I add another object over here, let's say a thinned out cube, a simple, very thin pole, add over here and align it, and then I use stitch and scoop to combine them, it actually did work. And it made it manifold. So despite the fact that it's not manifold, in some cases if you add something and combine them, stitch and scoop will still work and make it work. But still, I think in this example this was the cleanest idea how to make it work. Okay, so now let me show you some other examples. Let's say if I take this shape and I'm going to mirror this over, so I can make it a closed shape, and I'm going to I have to have the option create a copy, and I mirror over to the back. So now I have these two separate shapes. I'm going to join them together using the combine tool, merge, and I expect it will actually remove two vertices at these two intersection points, which we'll discuss later, the idea of merge vertices. So it removed two vertices, so now this is closed. Now because this is closed and the only volume intersect is over here, and this is considered inside faces, extrude actually would remove it. So I wouldn't be able to, it will remove it, actually will keep the design over here, so I can kind of play with it later. But for what I want to do now here is, it's easier for me to use the fill polygon tool, and I'll close it, and I'll go to polygon selection using part selection to remove the inside part, just to select it, and I'm going to delete it. Okay, so now what I'm going to do here, actually I didn't need part, it's a single face, I could have used simple face selection I think as well. So let's see, actually, if I do something like this, I can just go to face selection and simply select, it is two faces, okay, so I wouldn't need to click twice. Nevertheless, if I do now extrusion or add thickness, doesn't matter which tool I use, I got this shape, and again, this is non-manifold, the same problem. Now I can use the same solution as before, play in each corner, but now I have 4 corners to play with, and this becomes complicated. So the easiest way over here is I'm simply going to delete the inside faces. And I'm showing this example actually that I've reviewed a real object with these type of problems, and this is how I solved it. So I deleted the inside faces, and then I went to fill polygon to close it. So now this is closed like this. Now, if you still want to have the hole, what you can do is, there's a few options. You can go inset, let's say inset it only by 1, and then I can simply extrude them -100, because I know the height is 100, and in this case it will cut it out. Now, I'm not going to go into details extrusion cutting, I've covered that in another video, but this only works because the entire bottom side is flat, so there's no problem, no intersection, everything is flat. If it's not flat, you can simply copy this face, and you can extrude this face more. So I'm going to extrude this by, let's say, -110, and this over here. Now, because SelfCAD doesn't allow you to go below the grid, this actually the entire 10 extra pushed up on top, and also because I did negative extrusion, it actually flipped the normals, which is a good example to show from the previous use case. So first what I'm going to do is I'm going to move this up a little bit, doesn't matter how much, you can move it up by, let's say, 5 to be half, so it sticks out on both sides, and this is the same example I said before, where you have touching instead of intersection, so you always want to have it go out from one side a little bit. And now what I have to do here is I have to flip back the normals, which is again to flip normal example number 2, which is a good example how this can happen. I flip back the normals, and now if I take these two and I cut out this piece, this works perfectly fine. The only thing is when you do Boolean operations, stitch and scoop, it always gives you like these extra cuts. In some cases you can clean it up. For example, go resolution 0, and this actually cleaned it up, and this is how you solved this use case. And again, you can see over here, it did basically the same thing. It has this added thickness to each of the edges. Okay, the last example I want to show you actually is another typical use case that it might happen often. So if you add a basic cube, and then what if you want to add a staircase? People do that often. So I'm going to hold down my control key while I'm dragging, so it makes a copy, and you see it aligns it perfectly fine, so I know it's aligned at 100. Then I'm going to move it up to 100, something like this. So these two are one connecting each other, and again I'm going to use my combine tool, which should remove 2 vertices, and in this case we see it remove 2 vertices, so merge them together, and now I have the same problem. This is non-manifold. So I'm going to use again my edit details tool, but here a little bit you see again the message non-manifold. Here what I'm going to do is do a little bit different, add the details together with extrusion. So I'm adding here a section, I'm typing in again 5, you can obviously enter any value that you need. Oops, I entered 5, I moved it from bottom to top, so I needed to enter 95 in this case. Let me undo it. Okay, so either move it from top to bottom, or if I move it this way, it's 95. Okay, so now I'm gonna switch to face and select this face, and now what I'm going to do here is I'm going to extrude it by 5. Extruding by 5, and extrusion is also cutting. Again, I'm not going to go into many details of extrusion cutting, but you can see over here, actually it created these cuts over here. Everything is perfectly fine. Now this is already manifold, but now the problem here is that this is kind of an extra piece. It does not look nice. So here is where my edit details tool will again be helpful. I'm going to simply collapse this and collapse this and finalize, and now we have a nice volume because this section over here, the small piece, is open to this side, open to this side, so this makes it a proper volume. And this is how you solve edge only intersections and how you add the volume. Between these few examples that I've shown you, you should be able to solve probably almost every use case that you have. Number 5 is missing faces. Now, if you've seen the previous examples, you already know that fill polygons can close faces, but the thing is that there's some cases where you miss also edges. So let me explain the difference. So if I have this opened over here, the edges that needs to close this face, all of the sides exists because the edges are used for the other faces as well. What happened, however, if I delete an other face over here, now actually I'm already missing an edge over here on top. So if you use full polygon now, it may still work. It will find a solution to it. Actually, in this case, it did work. In some more advanced cases, it would not find a solution. It actually added the edge over here because it wasn't actually missing vertices. So if you think about it, the edge was missing over here, but the vertex in this corner, the vertex in this corner that makes up this edge was still here. What if I delete even this one? I delete completely everything. So now actually it's missing an edge as well. Now fill polygon will probably not be able to solve it unless it solves it wrongly. So to use these edges to close it, and then use this is actually not a solution. This is actually not solving it. So let me first show you the previous example where I still have this, how you can do it. I'll go to edit details again, and I'm going to add an edge. So I'm basically going to draw an edge from here, and actually I have to add not an edge, I have to add, yes, actually an edge, and I'm going to draw an edge. I'm going to draw an edge from this section to this section, and now it's closed because basically I'm adding the edge to automatically text. Now I cannot drag an edge because there's no place to drag it here. So if I go draw, I can add this edge. Okay, but now let's go to the other example where I delete this face as well. In this case, it's more difficult to add an edge. Let's see if it can actually work. Maybe I can or maybe not. No, actually I cannot, because if I add an edge like here, draw an edge here, it will close the top, and then it will kind of create this. It's missing some pieces. So in this case, what I can do here is I can add, instead of an edge, I can add a face, and I can start drawing my direction over here. So if I click here, it gives me a guide, and you see it highlights me where I'm intersecting this. Now it gives me this guide, so I can click over here, and now I can click here and click here. So I've added this face. Same thing now, I can actually just go and add an edge, make it easier, and simply add, draw in this edge over here, from here to here, and voila, it's closed. The only thing is, the way I've drawn this face, it actually flipped it, so only one face is flipped now. So I can go flip normals, and it's fixed. And actually I can try to remove these extra triangles with resolution 0, and this is fixed. Now obviously this was a simple use case, but these ideas could help a lot in other cases, and this is how you fix the problem with missing faces. Number 6 is self-intersection faces. This is another example where you can actually have this quite a lot. So let's say, for example, I'm going to scale this face, make this a little bigger at the top. Okay, I can either select the face and scale it, or let's say use the skew tool to do something like this, or the taper tool rather. And now I'm going to select this face, and I'm gonna, let's say, inset a little bit, let's say even a little bit more, let's say 10, and now I'm going to extrude that, bring it down. Now if I bring it down, at some point it starts self-intersecting coming out. Now because this goes down a straight line, and obviously the back is not the bottom side is shorter. Okay, so this is actually where this coloring, backface coloring, can show it, because when it comes out the inside out. In this case, flip normals would not help, because it will actually flip everything back and will be the opposite inside out. And this is because it's not a problem with flip normals, it's just that the inside is simply pushed out to the other side, and that means also they self-intersect. It just punches in the volume from the inside, from the one part goes into the volume from the other part. So how do you solve that? So the simplest way to solve it is actually simply to scale it back until you have no problem. So you scale it, make it shorter, something like this, and there's no problem. But what if you cannot scale it, or there's some problem you cannot do it? And this type of stuff is where Magic Fix comes in. Magic Fix can automatically fix everything, and depending on the amount of voxels, how you do it, they rebuild everything completely. You can see it rebuild it, but it has low voxels, and actually in some cases it creates halts, like in this cases. So you have to make it higher number of voxels, and will add more complications, more faces. And this is not the preferred solution for a case like this, because it's kind of at an angle. That's what Magic Fix is not really good at. I will link in the description extra other video where I describe Magic Fix and where they're good at and what it is. It's actually quite interesting, and Magic Fix can solve a lot of very complex problems that no other tool can solve, but this is not one of the good examples. So I'm going to show you another example where Magic Fix actually can do in a similar problem with self-intersecting faces. So let's say if I select, let's say, these two faces, and let's actually inset them a little bit, yeah, maybe less, kind of like this, and I'm simply going to push it out from the outside, the other side. So I'm kind of pushing it out. So in this case, again, you can see detect the self-intersection because the color, backface coloring, but now I need to combine them together, and this is more kind of planar, more flat, so Magic Fix should probably be able to solve it much better without distorting the object. And now if I do Magic Fix, you can see over here that this actually rebuilt everything completely, and what you can see here, if we're looking over here, it actually kind of added these sections over here, it rounded and it added, rebuilt it. It's everything completely rebuilt, but again, it kind of adds pixelization, kind of. You can add a higher number of pixels, but then we'll add even more polygons. Now I already have 100,000, and we'll add even more. But you can always simplify it and use the simplify tool and kind of reduce the poly count for such complex objects. And now it's down to 10,000. It's still good. But yeah, that's basically the last case where Magic Fix is. And again, as I said before, it's worth watching the other video, the link in the description, where actually in some cases Magic Fix is really helpful. But for these cases, it's much easier to solve it yourself. And simply, if you see these, if flip normal does not flip it, if you see they're simply pushed in, like flipped inside self-intersection, one thing pushes out from the other side, you simply push them back in, and that should solve it. Number 7 is duplicate vertices. If you watched all of the sections until now, you probably know already the idea how to remove duplicates. And I'll use a simple example I used before. If I use combine and merge them together, it will automatically solve this. To remove duplicates, will give you a message, 2 vertices removed. So it's hard to illustrate this actually. So what I'm going to do here is I'm actually going to use group instead of merging them, simply grouping them. And if I group them, they will not remove, it's just grouped without removing any vertices. And this is another example for actually the main example difference between group and merge, besides the fact that you can always ungroup it or click here and manage individual objects, parts of a group, or actually go over here also and use part selection and select just one section part from the group, but that's a different topic. But for now, the idea here is if I have something like this, these have duplicate vertices. So what you can do here is you can go to the geometry clean tool and they have an option remove duplicates. Now if it's going to remove duplicates, by definition it will also remove the group and make them as one object. So if you do it like this, it removes 2 vertices, and actually this is still a group, but if I'm going to move them together, let's say use part selection now, I'm actually not sure, I'm going to test now what will happen. If I'm going to move this away, yes, you can see actually it's kind of merged together. Like you can no longer move them without anything because they are combined. Still they behave as a group, but they're actually not a group anymore. So that's the problem with duplicate vertices. It's quite hard to do that, to find this problem, because almost all of the tools will automatically remove duplicates. But I did find some examples, like I did in my extrusion video. If you make the extrusion cut from 2 sides, actually that's a good example, so let me maybe show that quickly. I deleted only that part, I'm delete the entire thing. Okay, so if I'm going to, let's say, have an object over here, let's say make a copy of it, and simply something like this. And if I'm going to select this polygon and inset, and now extrude it, and I'm going to merge these 2 objects together or group them, doesn't matter, and I'm going to select this face and I'm going to extrude it to snap it until here, and if I just snap it, it should basically cut the intersection. You can see over here this is kind of cut over here, so this is no problem, nothing to remove. But what if I do the same thing in the other side? I select this face and I inset, and now I have these 2 faces over here, and I'm going to make the distance between them in the x direction to 0, so they basically come together like this. So this is an example where I actually have 2 faces. It's actually another example. I could have used extrusion both to extrude and collapse them at the same time, and because I'm going to both sides, it wouldn't cut. But actually in this case it's even worse, because it actually did not remove anything. So now you have not only duplicate vertices, but you also have the inside faces that are not combined, not removed. So again, geometry clean will do that. In this case you have to remove first the inner faces, and if you do something like this, it tells you 2 faces were removed, 2 polygons, 2 faces, same thing. And now I'm going to remove the duplicates over here, and it removed 4 vertices, 1, 2, 3, 4 in the bottom, and now this is a manifold object. So this finalizes it. I hope with watching it, so you know how to solve every non-manifold issue, and I hope you enjoy working with SelfCAD. Bye for now.